Now we're dealing with multiple layers, and we'd still like to train the network with gradient descent. For before, we know how to calculate the error in the output node. We can use this error with gradient descent to train the hidden to output weights. But to train the input to hidden weights, we need to know the error caused by the units in the hidden layer. How do we find these errors to use in the gradient descent step? Before, we found the errors by taking the derivative of the squared errors with respect to the weights between the input and output layers. If we do that with a hidden layer using the chain rule, we find the error for units there is proportional to the error in the output layer times the weight between the units. And this makes sense. A unit with a stronger connection to the output node is going to contribute more error to the final output. Here you see the error times the weights. This is the same way you propagate inputs through the network, the inputs times the weights between the layers. Instead of propagating the inputs forward, you're propagating the error backwards through the network. Now you can view this process as flipping the network over and using the error as the input. This method is called backpropagation. And this process works the same when you add more layers. You just keep propagating the errors through the layers. Backpropagation is fundamental to how neural networks learn. So it's really important to understand this if you're going to be building deep learning models.